If you break your arm, the X-ray shows this clear, jagged line, right? The doctor points to it, and it's just binary, broken or not broken.
Right, there's no ambiguity there.
Exactly. We rely on that visual, undeniable proof. But when you dive into the world of retail point-of-sale data, there is no X-ray machine. You are relying entirely on this fragile, basically invisible handshake between a physical chunk of steel on a counter and a cloud database somewhere.
And if that handshake fails, if the data parser misinterprets a single hex character, a business can bleed thousands of dollars a month.
And they would never even know why. So, welcome to the deep dive. Today, we are looking at the actual mechanics of that invisible handshake. We are pulling apart the architecture of a point-of-sale system called Register POS.
Which is created by a company called Ability Business.
Right. And specifically, we're looking at how their software handles the sell-by-weight feature. For you, the learner listening to this, buying a pound of apples or an ounce of chocolate seems so incredibly simple. But our sources today, which are a technical blog post and an explainer video transcript from the developers, they completely reframe what is actually happening.
Yeah, it's honestly an engineering problem that's just masquerading as a simple customer service interaction.
Totally. So our mission today is to unpack the technology, the math, and the strict legal compliance required to make that checkout fast and frictionless.
Because you look at a scale, and you probably assume it's just a digital readout, right?
Mm-hmm.
Just a localized event. But the documentation from Ability Business outlines this highly granular ecosystem.
Which is wild to think about.
It really is. What's fascinating here is that they are dealing with continuous analog to digital conversion, legacy serial communication protocols, real-time database queries, and state-level legal compliance. And all of that executes in, the 2 seconds it takes a cashier to move an item to a bag?
2 seconds, yeah. And that brings us to this specific analogy from the explainer video that I actually want to challenge immediately.
Oh, the cello analogy.
Yes. So they tell you to think of the checkout process like a perfectly tuned cello, which on a poetic level, sure, it sounds great. But from an engineering standpoint, why a cello? Why not, say, a drum kit?
Well, a drum kit is just a series of discrete impacts, right?
Exactly. You hit the snare, it triggers one single sound. And that is actually how a traditional barcode scanner works. It reads a UPC, fires an interrupt to the processor, and sends a discrete string of text. Boom, done. But a scale isn't a drum.
No, not at all.
A cello requires continuous, exact tension. The resonance has to be maintained dynamically by the player. So if you think about it, a scale is constantly reading physical mass and translating it to digital data.
That is exactly the distinction, because a commercial scale is fundamentally a dynamic instrument. Inside that metal platter you see at the deli, there's a load cell.
Which is what exactly?
It's usually a piece of machined aluminum or steel, and it has these little strain gauges bonded to it. So when you place an object on the platter, the metal physically deforms.
Wait, it actually bends?
Yeah. Usually by just a fraction of a millimeter, but it bends. And the strain gauges measure that physical deformation by changing their electrical resistance. So it's not a single discrete event like scanning a barcode. As long as that object is on the platter, the load cell is in a state of continuous tension.
Outputting a continuous analog electrical signal.
Exactly.
Okay, so that continuous analog signal is where the tuning part of the cello analogy actually holds weight. The software doesn't just ask the scale for a number once. The Register POS system has to establish a constant state of harmonic communication.
Right. They talk about the hardware and software talking in complete harmony during the setup phase.
Which is kind of marketing speak, right?
Yeah. If we strip away the marketing speak, they're talking about establishing a continuous polling loop, or a broadcast listening state that doesn't overwhelm the local CPU, but remains instantly responsive.
So it's always listening.
Exactly. The transition from the physical world, that bending of the load cell to a digital screen, is the crucial part. The explainer video highlights the instant capture of this weight.
And instant in software terms means something very specific.
Right. It means the POS application is likely sitting on an asynchronous thread, just constantly listening to the buffer. The millisecond the mass on the load cell stabilizes, the scale sends the digital weight string, and the POS software instantly plucks it from the buffer.
And for you, the listener, this completely transforms how you should view a mundane retail transaction. The point-of-sale terminal ceases to be a passive ledger where a human types in data. It becomes an active monitoring system.
Because relying on human transcription for highly variable items like bulk goods or fresh produce is just a nightmare.
Okay, let's unpack this for a second, because some Someone might be thinking, isn't a scale just a scale? Why does the POS software need to do all the heavy lifting? Why can't the cashier just read the screen and type it in?
Because of manual mathematics errors. The sources explicitly mention the elimination of messy errors.
Humans are terrible at typing decimals quickly.
Exactly. If a cashier is manually reading an LCD screen and typing 1.43 pounds into a keyboard, they're going to make mistakes. And a localized transcription error doesn't just mean a customer is overcharged by a few cents.
It corrupts the entire back end, right?
Yes, it completely corrupts the inventory and financial reconciliation process. Let's say you're buying expensive artisanal chocolate. The physical reality is 1.43 pounds, but the cashier accidentally types 1.34 pounds because of dyslexia or just rushing.
So now the database thinks it has more chocolate than it actually does.
Right. And that cascades directly into the financial software. Both the blog and the video emphasize this seamless syncing to QuickBooks Online.
Which is huge. It's not just dropping a daily revenue total into a ledger at the end of the night. Every single ounce and every cent flows cleanly into the accounting software.
What's fascinating here is they use the phrase clean, seamless finish. In retail accounting, a clean finish means zero variance.
No missing money, no missing inventory.
Exactly. The POS acts as the single source of truth. There's no manual end-of-day reconciliation where a tired manager is trying to match up raw weight tickets from the deli against the cash register receipts.
That sounds like a nightmare.
It is. But with this system, the financial ledger perfectly mirrors the physical displacement of inventory. It protects the business's margins without any manual entry.
But getting to that point of absolute flawless synchronization requires a workstation setup that honestly sounds more like setting up a 1990s mainframe than a modern deli counter.
It really does.
The explainer video dives into configuring COM ports, baud rates, and read command codes. And when I read that, I was like, wait, are we setting up a dial-up modem?
Yeah, it sounds incredibly archaic.
We live in an era of plug-and-play USB and Bluetooth.
Why does this team need such granular control over legacy communication ports?
Well, it's actually an environmental necessity. A commercial grocery checkout is a brutal environment for sensitive electronics.
Because of the electrical noise. Yes. Massive electromagnetic interference, or EMI. You have huge refrigeration compressors kicking on and off. You have high-torque AC motors in meat slicers right next to the scale.
Oh, wow. I didn't even think about the meat slicers.
Right. And USB operates on a tiny 5-volt differential, which is highly susceptible to EMI dropouts. But the legacy RS-232 serial protocol.
The one that uses COM ports and baud rate.
Exactly. RS-232 operates on high voltage swings. It is an absolute tank of a protocol. It can push data right past the humming refrigeration unit without dropping a single bit.
So that's why commercial scale manufacturers still use it.
Yes. And that's precisely why Ability Business has to expose these granular configurations to the end user. The software cannot auto-negotiate an RS-232 connection the way your laptop auto-negotiates a USB mouse.
You have to explicitly tell the software, hey, I'm plugging the scale into communication port 3, and the hardware is going to scream data at exactly 9,600 bits per second.
Right, the baud rate.
And if you get that wrong, like if you set the POS software to listen at 19,200, but the scale is transmitting at 9,600.
The software just receives absolute gibberish. It translates the waveform incorrectly into nonsense characters.
Which brings us to the read command codes mentioned in the video. Why are those necessary?
Because not all scales broadcast their weight continuously. Some operate on a polling system. The POS software has to send a specific hexadecimal or ASCII string down the line to the scale.
Like a secret password.
Kind of. It's the software essentially tapping the scale on the shoulder and saying, hey, transmit the current weight right now. The scale receives that command code, processes it, and fires the data string back.
And the blog points out that during this internal setup, you also have to define the maximum capacities and set precise accuracy levels in the software, so it has to match the manufacturer's exact specifications.
Which is crucial for data validation.
Right, because if your scale is physically capped at 30 pounds, but a glitch sends a data string claiming a weight of 85 pounds, the POS software needs an internal sanity check.
Exactly. By defining those limits at the configuration level, Register POS can instantly reject anomalous data before it corrupts a transaction.
Okay, so that's the hardware configuration layer. But then there's the item level configuration. The blog outlines this final setup step where you have to go into the inventory system and specifically enable the sell by weight option on applicable items.
Which seems obvious, right? You don't weigh a prepackaged box of cereal.
No, you just scan the barcode.
Yeah.
But from a software architecture perspective, this is a vital routing mechanism.
Yes, it changes the entire checkout flow.
So picture this. The cashier taps a hotkey for bulk almonds. The POS software queries the local database. The database returns the record, sees that the Boolean flag for sell by weight is toggled on, and that triggers a hard interrupt.
Right. The software temporarily pauses the normal transaction loop.
It opens the COM port to the scale, sends the read command code, waits for the valid serial response, parses the weight, multiplies it by the unit price, and appends the total to the receipt.
And all of that has to happen in milliseconds.
Which is why both sources heavily emphasize the testing phase. You have to test everything to ensure the workstation, the scale, and the item configuration are perfectly aligned before you ever put this in front of a live customer.
Because if there's a typo in the read command code or a missing flag in the database, the cashier is just left staring at a frozen screen.
The transaction loop just hangs.
Exactly. The software is waiting indefinitely for a serial response that is never coming.
So it's basically the dress rehearsal for our cello analogy.
Precisely. But, here's where it gets really interesting. This entire ecosystem relies so heavily on the specific firmware of the physical scales.
Right, the hardware compatibility.
The blog explicitly lists the popular manufacturers they support. The big three, basically. Avery Weightronics, CAS, and Mettler-Toledo.
So if you own one of those, Register POS probably has their serial parameters preloaded as drivers. You just select it from a dropdown.
Right. Very easy.
But what if a store doesn't have one of those supported brands? Let's say a boutique deli spent $3,000 on some highly specialized, obscure scale from a German manufacturer 10 years ago. They want to upgrade to Ability Business's software, but their hardware isn't on the list. Are they just locked out of the ecosystem?
No, and this is a massive selling point. Ability Business offers custom configuration services for unlisted devices. They don't just tell the customer to throw away their expensive hardware.
That would be a deal breaker for so many small businesses.
Absolutely. So instead, they offer to map the, quote, correct serial output data directly into the POS system.
Okay, if we connect this to the bigger picture, what does mapping serial output data actually imply for their development team?
Well, it means they're writing custom middleware. Every proprietary scale outputs a different serial stream.
It's not just a clean number like 1.5.
No, not at all. A legacy scale might output a raw string that is just an absolute mess of characters. Start bits, stop bits, status codes, the unit of measure, the gross weight, all crammed into one line of text.
Like a Mettler-Toledo scale might output a hexadecimal string that translates to a start character, a few numbers, a decimal, and a carriage return.
Right. But an obscure brand might output something completely different. So to map this data, the developers have to write a custom parsing script, likely using regular expressions.
As JAX, right.
Yeah. Their software intercepts that raw proprietary digital signal, strips away all the garbage formatting, finds the exact sequence of bytes that represents the actual weight, and translates it so Register POS can understand it.
It's basically a real-time translation layer, and that ensures no business is locked out just because of their hardware choices. They don't have to rip out their entire physical counter setup just to get their data to sync with QuickBooks.
Exactly. It brings legacy hardware into the modern cloud-synced era. But speaking of translating physical data, we have to talk about a concept that fundamentally protects consumer trust.
Yes. Returning to the physical reality of the product. The blog brings up a very specific, crucial detail called software tear weight.
Which is such an important feature.
So tear weight is the weight of the packaging, right? The system needs to automatically subtract the weight of containers or trays so the customer isn't paying for them.
Right, because you are paying for the product, not the packaging.
I mean, imagine you're buying some really expensive specialty chocolates. They're like $30 a pound. You do not want to pay $30 a pound for the heavy glass tray the cashier is weighing them on.
No, that would be incredibly frustrating. And it happens.
But historically, tear was a hardware function.
Yeah. The cashier puts an empty tray on the scale, presses a physical tear button to zero it out, and then adds the product.
So why pull that function away from the hardware and put it entirely into the software? Why is that such a big deal?
Because relying on hardware tear relies on human memory. And human memory is the weakest link in any data chain.
That makes sense.
If the cashier forgets to press the button, the customer is overcharged. Or worse, if they tear a heavy glass tray for one customer and then the next customer buys something in a light paper bag.
Oh, and they forget to clear the tear.
Exactly. The scale reads a negative weight or severely undercharges the next customer. By making this a software feature, you are automating fairness.
The software automatically knows to deduct the tray's weight. So the blog says this ensures, quote, customers only pay for the product itself.
It builds trust, prevents accidental overcharging, and totally streamlines the cashier's workflow.
Let's look at how that actually works under the hood. The POS software isn't just randomly subtracting numbers. It requires a relational database setup.
Right, there's logic to it.
You have your master SKU table with the items, like truffles, and the software knows that those truffles are always sold in glass container B. Someone in the back office already weighed glass container B, let's say it's half a pound, and logged that into the system.
Precisely. So when the transaction happens, the physical scale on the counter actually transmits the gross weight.
Meaning the truffles plus the glass tray?
Yeah, the scale doesn't know what it's weighing. It just sends the total mass. So the POS software receives a gross weight of, say, 1.5 pounds. It queries the database, sees the software tear weight is 0.5 pounds, subtracts it locally, and charges the customer for exactly 1 pound.
It's completely invisible to the cashier. They don't have to push any extra buttons. They just weigh the item and smile.
And it prevents employee theft, too. An employee can't manipulate the physical tear button to undercharge a friend because the software bypasses that completely.
It centralizes all the operational logic. But, as much control as the software exerts over this data, there is a hard boundary they absolutely cannot cross.
And it's a literal legal boundary.
Yes, we are moving from the software's internal checks and balances to the legal checks and balances mandated by state law, because there's a really interesting pivot in the blog source.
Where they hand off the hardware support.
Exactly. Ability Business makes this incredible software. They do custom mapping, they do software tear, but they, quote, strongly recommend purchasing and servicing the scale through a qualified local scale dealer.
Yeah, they explicitly state all hardware issues must be addressed by your dealer or manufacturer.
So what does this all mean? Why would a software company build this flawless digital ecosystem and then completely wash their hands of the physical hardware?
This raises an important question about state regulations. They use the phrase legal for trade certification.
Which sounds very official.
It is. Selling goods by weight is a heavily regulated activity in the United States. It's governed by the National Conference on Weights and Measures, specifically a document called NIST Handbook 44.
So you can't just buy a cheap digital scale off the internet, plug it into your COM port, and start selling deli meat.
Absolutely not. The specific model of the scale has to be evaluated and certified under the National Type Evaluation Program. It has to be legally designated as legal for trade.
Meaning it operates within strict, legally mandated tolerances for accuracy.
Yes. And a local professional is required for the physical setup and routine calibration.
Because an inspector from the local Department of Weights and Measures actually visits the grocery store, right?
They do. They place highly calibrated test weights on the scale. And if it passes, they put a physical seal on it, like a lead wire seal or a tamper evidence sticker.
Oh, wow. So you physically cannot open the scale to mess with it.
Right. It legally prevents the business owner or a remote software developer from going into the scale's menu and adjusting the calibration to rip off customers.
So a software engineer in another state cannot legally recalibrate a physical scale over the internet?
Exactly. If the load cell drifts because of mechanical fatigue, you cannot just adjust the software to compensate.
Yeah.
That is illegal.
The physical instrument must be mechanically tuned by a local licensed professional who can legally break that inspector's seal, fix it, and reseal it.
Which is why Ability Business has to draw that line. The explainer video touches on this, saying local tuning and calibration ensures the resonance is perfect.
It's a massive liability shield for the software company. But hardware reliability isn't just about legality, right? The blog says it protects your margins.
Yes, and that works both ways. If your scale is audited and found to be reading heavy, meaning you are overcharging customers, the fines are astronomical.
And the PR damage would be terrible. No one wants to shop at the store that cheats you on meat.
Exactly. But mechanical drift often results in scales reading light.
Meaning the business is undercharging.
Right. If a deli scale is off by just a fraction of an ounce on the light side, the business is giving away free product with every single transaction.
Oh, wow. Over a year in a busy supermarket, that could be thousands of dollars in lost inventory.
Easily. And the software tear and the QuickBooks integration will never catch it because the POS software just blindly assumes the hardware is telling the truth.
So that local tuning and calibration ensures the business, quote, never misses a beat. It ties the digital accounting system to physical reality.
It really does. It reveals the massive engineering infrastructure hiding behind these mundane daily tasks.
It's incredible. So just to synthesize this whole deep dive, doing something as simple as dropping a bag of apples on a checkout scale requires an absolute symphony of technology.
Yeah, a symphony of baud rates, CM ports, QuickBooks API integrations, software tear calculations, and local legal compliance.
All happening in a fraction of a second just so the cashier can weigh an item and smile at you.
It's brilliant.
For those of you listening who actually want to experience this real-time point-of-sale architecture, the sources provided exact contact information. You can visit abilityregister.com. You can email Mike directly at sales@abilityregister.com. And actually, the video transcript notes it as sales@abilityregister.com, which is probably just a transcription quirk. Or you can just call them at 1-866-992-2454.
And I just leave you with a final thought to mull over. Next time you place an apple on a grocery scale, just think about that invisible digital handshake occurring.
Yeah, think about the physical gravity of that piece of fruit.
Exactly. The gravity is being instantly translated into legal compliance, accounting data, and economic value, all in a language of serial output data. It perfectly bridges the gap between the natural world and the digital economy, all before you even pull out your wallet.
From physical gravity to a perfectly tuned digital ledger, we hope this deep dive gave you a totally new perspective on the invisible systems running the world around you. Until next time.